Next, we'll look at exponential decay, and the only difference between exponential growth and exponential decay is that your value for k is negative when you have decay. All right, so there's something called the half-life of a substance. You may have heard of this before, usually referring to radioactive substances. The half-life of substance is the time it takes for an original amount of a substance to decrease to half the original amount. Here's an example. A doctor prescribes 125 milligrams of a drug that decays 30% each hour. Find the half-life of the drug and write an exponential function that models the amount of the drug in the patient's system after t hours, and how much would remain in the patient's system after 3 hours. You can see why this might be an important kind of problem to be able to solve, because doctors might want to maintain a certain amount of medication in a patient's bloodstream, and so knowing the decay and how long it takes will help doctors know how often to prescribe the drug to be taken. All right, so here's our model. Y is equal to a sub 0, e to the kt. Find the half-life of the drug. So remember, just like when we did the doubling, it really doesn't matter what we start with. I could start with 125, but that's, if I divide that by 2, it's going to be a decimal. So why don't I start with something friendlier? So why don't we say we start with 10 milligrams in the patient's bloodstream? Okay, and it decays 30% per hour, so I know my k is equal to negative 0.30 times t, and I want to know the half-life. I'm trying to figure out how long it takes for this to happen. How long will it take for there only to be 5 milligrams left in the patient's bloodstream? All right, so we're just going to go ahead and solve this equation. We'll divide both sides by 10, and here we have 5 over 10, or in other words, 0.5. And no matter what amount you decided to start with, in this first move where you do the division, you'll always end up with 0.5, in other words, half, is equal to e to the negative 0.30 times t, taking the natural log of each side and then bringing down the power. So we have the natural log of 0.5 is equal to negative 0.30 t, natural log of e. Natural log of e we know is equal to 1, so all we need to do in this problem is divide both sides by negative 0.30. So we'll take the natural log of 0.5 and we'll divide that quantity by negative 0.30, and it gives us a time of 2.31. So roughly every 2.31 hours, the drug is reduced by half. How much would remain in the patient's bloodstream after 3 hours? Well, now we have our model. So we can say y is equal to, our initial amount was 125, e to the k we know is negative 0.30, and the time we're given in this problem is 3. So all we have to do is enter this into our calculator. So we have e to the negative 0.30 times 3 power multiplied by 125, and this gives us 50.8 milligrams. Let's do another one. A scientist begins with 250 grams of a radioactive substance. After 250 minutes, the sample is decayed to 32 grams. Write a function that models this exponential decay. What is the decay rate? All right, y is equal to a sub 0 e to the kt. So a sub 0, our starting amount, is 250. This is our time. Coincidentally, also 250. I should have picked a different number. I apologize. The sample has decayed to 32 grams, so this is our final amount. And these 3 values will help us solve for k. All right, so here we go. 32 is equal to 250 e to the where is my minutes? Oh, here we are, 250 k. We'll divide both sides by 250, divide by 250. So we have 32 divided by 250 is equal to e to the 250k. We'll take the natural log of each side, allowing us to bring down the power. So the natural log of 32 divided by 250 is equal to 250k times the natural log of e. We'll divide both sides by 250, and that'll give us a value for k. So the natural log of 32 divided by 250 gives us a value of k of negative 0.0082. And again, we were expecting a negative value because this is decay. Find the half-life of the substance. So let me go ahead and fill that in. So our model is A is equal to A sub 0 e to the negative 0.0082 times t. To find the half-life, again, pick any number you want for your starting amount. The result will be half of that, e to the negative 0.0082 t. Dividing both sides by 10 gives us our starting point of 0.5 is equal to e to the negative 0.0082 t. And then you would go ahead and solve it just like before. So I'm going to stop here, and why don't you go ahead and solve it.